video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. This is third session of orthographic projection chapter. In this session we are going to solve one example. Here one 3D object is given. As per given data, draw front view from X direction, top view and left hand side view for the given figure using first angle projection method. Here you can see X direction is given for front view. So this line indicate length, this vertical line indicate height and this line indicate width. This is our front view direction. So according to front view, this is our left hand side view direction and top view direction always fixed from top side. From front direction, we can see length and height. From side direction, we can see width and height. And from top direction, we can see length and width. From front direction, we cannot see width. From side direction, either left or right side, we cannot see length. And from top direction, we cannot see height. Next, find out total length, width and height of this 3D object. Total length is 80 mm, 30 plus 30 plus 20. Total width is 50 mm, 15 plus 20 plus 15 and total height is 45 mm, 35 plus 10. Here you can see the location of front view, top view and left hand side view with reference to axis. According to first angle projection method, front view draw above XY line, top view draw below XY line and left hand side view draw right side of front view. Next, draw front view, top view and left hand side view box with reference to XY. Draw front view box above XY, front view box which cover maximum length and maximum height. Below XY line, draw top view box. Top view box cover maximum length and maximum width. Length is common in front view and top view box. So transfer length from front view and complete top view box. Here this vertical line indicate width of given 3D object. Next, locate left hand side view box. Left hand side view box draw right side of front view and front view and left hand side view separated by x1 y1 axis. Left hand side view box cover maximum width and maximum height. Now height is common in front view and inside view. So transfer height projection from front view. Width is common in top view and inside view. So width is transferred from top view. For width transfer, draw 45-degree angle line from common intersecting point of xy and x1 y1 axis and transfer width in left hand side view. Here the common intersecting area of height and width projection will represent here left hand side view box. Next, for easy to visualization, divide this 3D object into different surfaces like A, B, C, D, E, F, G, H, I and J. From front direction, visible surfaces are A and J. From left hand side view direction, visible surfaces are B, C, D, F, G, H which cover width and height. From top direction, visible surfaces are B, D, E, I and J which cover length and width. So first draw visible surface in front view box. Let us draw A surface in front view box. For A surface, take maximum length 80 mm, 10 mm height, then 20 mm length, then 35 mm height, then 30 mm length, then 25 mm height, 20 mm length. Now for this inclined line location, connect these 2 points. So this is indicate A surface in front view. Next locate J surface in front view box. Now this rectangle indicate J surface. This inclined line of J surface is projected as a straight line parallel to height, and this is 20 mm length line. So this rectangle indicate J surface. Next draw visible top view in top view box. Now in front view and top view length is common, so transfer all lengths in top view. First locate eye surface in top view. The width of eye surface is 15 mm. So locate 15 mm width. Next locate length 20 mm of eye surface. So this is 20 mm length. Next locate remaining width in top view box. Next locate 30 mm length. From this point locate width line of eye surface. The size of this line is 10 mm because diameter of this semicircle is 30 mm, radius is given 15 mm, total width is 45 mm, so width of this two line is 10 mm. So from this point take 10 mm width. Next locate center point of this semicircle. Radius is given 15 mm. So take 7.5 mm distance and locate parallel to length center line. From this center point draw semicircle. Next draw 10 mm width line. At last connect these 2 points. So this is indicate eye surface. Next locate E surface. Now first draw 20 mm length line of E surface from this point. Next locate 10 mm length line, then 20 mm width line, again 10 mm length line and 15 mm width line. At last connect these 2 points. So this is indicate E surface. Next locate B and D surface. Now here the B and D surface actually slant surface, but from top direction we can see these two surface as a flat surface. So this inclined line of B and D surface is become straight parallel to length. So first draw inclined line of B surface as a straight line. Next draw 15 mm width line. Next draw inclined line of this B surface as a straight line. Here this rectangle indicate B surface. Similarly locate D surface. Draw inclined line of D surface as a straight line parallel to length. Next locate 15 mm width line. Next draw second inclined line as a straight line parallel to length. So this rectangle is indicate D surface. Now here this area indicate J surface. From top direction we cannot see height, so this inclined line is projected as a straight line parallel to width, and locate this length line. So this rectangle indicate J surface. Next draw visible surface in left hand side view box. From left direction we can see B, C, D F, G and H surface. First locate B surface. The height of B surface is 20 mm. So first transfer height 20 mm from front view. The width of B surface is 15 mm. So transfer 15 mm width from top view. Similarly, for D surface, transfer this 15 mm width from top view. Here, this rectangle indicate B and this rectangle indicate D surface. From side direction, we cannot see length, so this area indicate C surface. Next, locate F, G and H surface. The width of F and H surface is 10 mm. So transfer 10 mm width from top view for F and H surface. Here, this area indicate F surface and this area indicate H surface. From left hand side view direction, this curved surface is projected as a flat surface. So this area indicate G surface. So this is visible front view, top view and left hand side view projection. Next, draw hidden projection in front view. From front direction, we cannot see this surface. So project length for this surface from top view and locate height line as a hidden line because this line we cannot see directly from front direction. Next, locate G surface in front view. From front direction we cannot see circular G surface. From front direction, G surface is projected as a flat surface but it is not directly visible. So first take length projection from top view. This arc is become straight parallel to length and locate height of the curved surface. So this rectangle indicate G surface which is invisible from front direction. Next, locate hidden projection in left hand side view. From left direction we cannot see J surface. The inclined line of this J surface we cannot see directly visible. So take 10 mm height projection from front view and locate this inclined line as a hidden line in left hand side view. Here width is given 15 mm and this is the projection of 15 mm width. So connect these 2 points and this inclined line indicate hidden surface of J. Next, locate length, width and height dimension as per given in this 3D figure. Here locate 30, 30 and 20 mm length. Next, locate 15, 20 and 15 mm width either in top view or in left hand side view. Next, locate 15 mm radius for this semicircle. Next, locate 20 mm length, 10 mm height of this A surface, 20 mm height and this 25 mm height for F, G and H surface. Next, locate 10 mm width, 30 mm width and 10 mm width for F, G and H surface. Here one thing remember, locate length dimension either in front view or in top view. Width dimension locate either in top view or in side view. And height dimension locate either in front view or in side view. So here this is the end of this session. See you soon in next coming video lecture. Thank you.